Hello everybody and welcome to my poster presentation at the 29th International Material Research Congress. I'm going to give you a short overview of my poster entitled Photoluminescent Coumarin Grafted Polyethylene Films as Chemosensor for Metal Ion. This work has been performed at the Institute of Material Research at UNAM in Mexico City, and the irradiation experiments were performed at the Nuclear Science Institute at UNAM in Mexico City. First, I'm going to give you a brief overview about the fluorescent chemosensor. So, what are fluorescent chemosensors? Fluorescent chemosensors are developed to take advantage of light emission for the detection of non-fluorescent analytes. The photo-induced electron transfer quenching mechanism is the most employed transducing mechanism to indicate the presence of the analyte. When an amine group is appended to a chromophore, it usually induces fluorescence quenching. When the amine group is then protonated or interacts with a metal ion, the initial fluorescence of the chromophore is restored. Small molecule chemosensors have found applications in solution. However, for different types of applications, such as detection of heavy metal in water, it would be useful to have the sensor on a solid support. Therefore, the goal of this project was to obtain a test paper-like chemosensor that would be reusable for the detection of metal ions in water. We propose to use gamma radiations to covalently attach the designed chemosensor to the solid support. The chosen polymeric material is polyethylene, and the chromophore is a Coumarin chromophore with an appended diethyl amino group. On the left of the screen, you can see the scheme for the grafting of the polyethylene films. The films were grafted first with acrylic chloride using different doses of gamma radiations. Afterwards, they were reacted with the previously synthesized Coumarin derivative. On the right of the screen, you can see the absorption and emission spectra of the Coumarin derivative. It is shown in chloroform as well as in the film. It can be observed that the spectra are almost superposed. The grafted polyethylene films were used as chemosensors for zinc and copper ions. An increase in the fluorescence emission was observed after submersion of the polyethylene films in a solution containing zinc ions. The film was washed with EDTA and the initial spectra was recovered. The immersion of the film in a solution containing copper led to a decrease in the fluorescence emission. At the same time, a color change from transparent to green was observed by naked eye. The film could be washed with EDTA and reused several times. TDDFT calculations were performed on the Coumarin derivative to investigate the quenching mechanism. The energy level of the lone pair of the amine moiety was slightly lower than expected for a very efficient PET quenching. However, its participation in the transition state was sufficient to explain the experimentally observed results. In conclusion, we have obtained a solid supported chemosensor presenting fluorescent enhancement after the interaction with zinc and fluorescent decrease together with a color change in the case of copper. This chemosensor is reusable and functions as a test paper-like sensor. As a perspective, we have seen that DFT calculations are a valuable tool for the design of a more efficient PET-based sensor. We are working on different receptors for a better interaction with the metal ions. Furthermore, a hydrophilic solid support for a better response in aqueous media will be studied. Most of this work have been published, so please check our reference number 4. With this, I come to the end and I will be happy to answer any questions. Thanks for watching!